Hello. This is the project explanation video of Group R versus R. The title is Comparison of R290 as an alternative refrigerant for replacing R32 in a domestic split-type air conditioner. An air conditioning system is composed of a compressor, an expansion valve, a condenser, and an evaporator. The split-type air conditioner comes to the market as two parts: indoor unit, outdoor unit. Objectives of this project. Number 1. Compare the thermodynamic properties of R32 and R290. Number 2. Assess the energy efficiency of R32 and R290 in air conditioning applications. Number 3. Evaluate the safety considerations associated with these refrigerants. Number 4. Analyze the environmental impact of these refrigerants. Under thermodynamic property comparison, a literature survey had happened between the two refrigerants. While investigating the thermodynamic property tables, behavior of thermodynamic properties like pressure, temperature, enthalpy, specific volume, and density was investigated in this phase. To compare the energy efficiency of R290 and R32, we need to calculate the compressor power consumption and the coefficient of performance value for both cases theoretically and practically. Safety is a major consideration for AC systems. Effect of the leakages, flammability, and the toxicity were considered here. R290 is flammable, requiring specific safety measures. R32 is non-flammable but may cause slight toxicity. Impact for the environment was measured with global warming potential and ozone depletion potential. R290 has a global warming potential of 3, which is extremely low compared to R32, which has a global warming potential of 675. Ozone depletion potential for both these gases are negligible. HFCs are used as a primary refrigerant in most applications. However, HFCs are now being phased out due to their contribution to climate change. According to the timeline, now we are at the week 9 calculation and analysis stage. Under the calculation stage, using thermodynamic property tables and the energy balance, we calculated the coefficient of performance values for each case theoretically. For condenser at 40 degrees Celsius and evaporator at 10 degrees Celsius, the COP values were calculated. The result from this calculation implied that R290 has a higher COP value than R32. As for the pressure, R32 was than that of the R290, and for specific volume, R290 was higher. After the theoretical calculations and analysis, what is left in this project is the experimental analysis, recording the practical results. The real-world conditions for replacing R290 in a same unit used for R32, and find out what changes should be happened in this process, are the left tasks for upcoming weeks. The practical investigations will be done with the help of the technicians at the workplace. End result of this project will give you a detailed report on why we replace R32 with R290, how eco-friendly are the process, how the energy cost varies, how the labor cost varies, how likely it is to repair the spare parts, and how the overhead expenses vary after replacing R32 with R290 in a unit which is originally manufactured for R32. Vast majority of manufacturers have switched to R290 by now. Abans plc is planning on switching to R290. Therefore, we are collaborated with them to find out the most efficient way to do this replacement. After the practical investigation, hopefully we will be able to come up with the most efficient solution. Stay tuned with us.